students, welcome back to your favorite YouTube channel, Tomachang Tutorial. Myself, Kisum Kulum, and we are ready to go for chemical calculations, okay? We will do numericals related to stoichiometric equations. Got it? So let's begin. But before beginning the chapter, I would like to let you know that we have already discussed about law of conservation of mass in chemical reaction. We have already discussed about mole concept, and we have already discussed about how to balance a chemical equation. You can find the link below in the description. Go and find the link below in the description and watch that video to better understand this topic. Okay, let's go. Now, this is chemical calculations. To solve the numericals based on chemical calculations, what we need to first understand is there are only two formula. Okay, I am using mole concept to solve the numericals of this chapter. So please copy these two formula in your notebook and memorize it. Number one, number of moles. Okay, number of moles equal to molecular weight, given mass of the substance divided by its molecular weight. Okay, and number two formula is number of moles equals to given volume at STP, standard temperature and pressure, divided by its molar volume. Okay, molar volume at STP. Molar volume means molar volume means the volume of 1 mole of gas. Molar volume means volume of 1 mole of gas. And molar volume at STP is 22.4 liter, which means volume occupied by 1 mole of gas at STP is 22.4 liter. This is constant. It's given by Avogadro. Okay, Amedio Avogadro. We got this from Avogadro's law. Okay, these two are the formula which we should keep in mind while solving the numerical problems from this chapter. Okay, first our duty is to find the number of moles. If mass of the substance is given, or if mass of the substance is asked to us, both the cases, if the mass of the substance or weight of the substance is given to us, or if the weight of the substance is asked to us, then we must use number one formula. Number one formula applies to mass of the substance. Number of moles equal to given mass of the substance by its molecular weight. We can find the mass of the substance, or if the mass of the substance is given, we can find number of moles. Okay, and in the number two formula, if the volume is provided to us, or if we are asked to find the volume of the substance, then we must use number two formula. Number two formula tells us number of moles equal to given volume of the gas at STP divided by molar volume at STP. Molar volume of any gas at STP is 22.4 liters. We know that. Okay, 22.4 liters. Please remember this formula. We will solve all the numerical problems with these two formula. Okay, we won't use other method. We will understand this formula better while solving the numerical problems. Okay students, let us solve this numerical problem applying the formula which we have already memorized. Okay, the question is, calculate the volume of nitrogen required to produce 44.8 liters of nitric oxide at STP, okay, standard temperature and pressure. Nitrogen, how many or what volume of nitrogen produces 44.8 liters of nitric oxide gas? This is the question. What volume of nitrogen produces 44.8 liters of nitric oxide gas at STP. This is the question. First of all, we need to write a balanced chemical equation for this. Okay, nitrogen reacts with oxygen to produce nitric oxide gas, NO gas. Nitrogen gas chemically reacts with oxygen gas to produce nitric oxide gas. Now let us balance this chemical equation. N is 2, O is 2. If I write 2 here, the equation will be balanced. 2 nitrogen and 2 oxygen. Okay, the equation is balanced. Now we are given 44.8 liters of nitric oxide gas. See, nitric oxide gas is how much? 44.8 liters, isn't it? Nitric oxide gas is how much? 44.8 liters. So volume is given to us. We will use the second formula, that is the volume related formula. First of all, our duty is to find the number of moles of nitric oxide, and then we will find the number of moles of nitrogen, and then we will find the volume of nitrogen. Okay, that's my point. Let's begin. Okay, since number of moles of NO equal to number of moles of nitric oxide equal to given volume at STP, isn't it? Given volume at STP divided by its molar volume at STP. I hope you remember this formula, isn't it? Because volume is given to us, so we need to use this formula. We cannot use the weight formula. Number of moles of NO is given volume at STP divided by its molar volume at STP. So the given volume of nitric oxide is how much? 44.8 liters. So instead of this, we write 44.8 liters. 44.8. Okay. And we know the molar volume of any gas at STP is how much? 22.4 liters, isn't it? Volume occupied by 1 mole of gas. Let us divide this to 1 jar, 2 jar, isn't it? The decimal point here is in front of 1 digit, and the decimal point in the numerator is also in front of 1 digit, so decimal points can be forgotten. So 2 to 4, 2 jar 4 4 8, 2 4 jar 8, 2 2 jar 4, 2 2 jar 4, isn't it? So number of moles of nitric oxide is how much? 2 moles. We got the number of moles of nitric oxide. Now we will find the number of moles of nitrogen, and then we will find the volume of nitrogen. Okay. So 2 moles of nitric oxide is produced from 1 mole of nitrogen, isn't it? 2 moles of nitric oxide is produced from 1 mole of nitrogen. So what will be the moles of nitrogen? 1 mole. See, you can see from the equation, 2 is in front of NO. So here 2 moles. You can say this 2 moles. 2 moles of nitric oxide is produced from, there is no number, means 1. 2 moles of nitric oxide is produced from 1 mole of nitrogen. Number of moles of nitrogen is how much? Number of moles of nitrogen required is how much? 1 mole equal to 1 mole, isn't it? So we need to find the volume of 1 mole of nitrogen gas. Volume of 1 mole of nitrogen gas. Okay. Since number of moles equal to volume given, volume of N2 divided by its molar volume. Molar volume is how much? 22.4 liter. Number of moles is how much did we get? 1. So 1 mole of nitrogen equal to this number of moles of nitrogen is 1. We have already found number of moles of nitrogen required is 1 mole. So 1 number of moles is 1 equal to volume of N2 required. Volume of N2 required divided by 22.4, isn't it? Let me continue this here. Okay. So volume of N2 required will be how much? 22.4 into 1, isn't it? Therefore, volume of N2 required equal to, you can cross multiply this, 22.4 into 1 is 22.4 liters. Okay, this is the solution. 22.4 liters of nitrogen produces 44.8 liters of nitric oxide gas when completely combines with oxygen. Okay, enough amount of oxygen. This is the way how we solve. First of all, if the volume is given, we use the formula for number of moles, which is related to volume, and from there we find the number of moles, and then we find the number of moles of the element or the compound which is asked, and after that we find the volume of that substance. It's very easy. Let us do question number 2 further. Okay students, let's go for another question to understand the concept of mole better. We have a question: how many grams of oxygen is required for 27 grams of aluminium? How many grams of oxygen is required for complete reaction of 27 grams of aluminium? Okay, let us first write the chemical reaction and then balance and then solve. Okay, aluminium, we know the formula for aluminium is Al, reacts with oxygen to produce aluminium trioxide, Al2O3, isn't it? Let us balance this chemical equation. If I write 3 means 2, 2Al, 4, 4Al. So 2 3 is 6, 3O2. 4Al, 6O2, 2 3 is 6O. Okay. This is balanced. Now, what is given to us? The amount of aluminium is given to us, 27 grams. Aluminium is given to us, 27 grams of aluminium. First, let us find the number of moles of aluminium, okay? And after that, let us find the number of moles of oxygen. And then we can find the amount of oxygen, okay? First, let us find the number of moles of oxygen. Since number of moles equal to given mass of the substance divided by molecular weight, isn't it? So given mass of the substance is how much? 27 grams, and molecular weight of aluminium is 27. So number of moles is 1. Number of moles of aluminium is 1. We have found out. Now, since 4 moles, this 4 can be read as 4 moles of aluminium require 3 moles of oxygen, isn't it? 4 moles of aluminium require 3, this 3 is in front of O2. 4 moles of aluminium require 3 moles of oxygen for complete reaction, okay? Since 4 moles of aluminium requires 3 moles. I am trying to find the number of moles of oxygen required, okay? 4 moles of aluminium requires 3 moles of oxygen, isn't it? So, unitary method, 1 mole of aluminium require 3 upon 4 moles of oxygen. We have 1 mole of aluminium, isn't it? So 1 mole of aluminium require 3 by 4 moles of oxygen. So the required number of moles of oxygen is 3 by 4, because 1 mole of this is 1 mole. 1 mole of aluminium means 27 grams of aluminium, isn't it? 1 mole of aluminium means 27 grams of aluminium. 1 mole of aluminium requires how much? 3 upon 4 moles of oxygen for complete reaction. Got it? So 3 upon 4 moles of oxygen means how much gram of oxygen? We are asked to find that. Let me erase this. Please take the screenshot of this. Okay, now 3 upon 4 moles of oxygen means 1 gram of oxygen. Okay, since number of moles equal to mass of O2 required divided by its molecular weight. Molecular weight, isn't it? Number of moles required is how much? 3 upon 4. 3 upon 4. So mass of O2 required, we copy as it is, mass of O2 required. Let me erase this. Divided by molecular weight of oxygen is how much? O2. Atomic weight of oxygen is 16 into 2. Oxygen is a diatomic molecule, so 16 to the 32. 32 is the molecular weight of oxygen. So let us cross multiply this 32 here. 3 into 32 divided by 4 equal to mass of O2 required, isn't it? Got my point? Now 4 on the 4, 4 is the 32. So therefore mass of O2 required equals to 8 3 the 24 gram. Okay, 27 gram of aluminium requires 24 gram of oxygen. This is how we solve numerical problems by the mole concept. First of all, when the mass is given, we need to find the number of moles. After that, whose mass is asked, we need to find the moles of that particular substance. After finding the moles of that particular substance, we can find the mass easily by applying the formula number of moles. Let us go for question number 3. Okay students, let us do another numerical problem to understand the concept of mole better. Calculate the weight of oxygen obtained on heating 24.5 gram of potassium chlorate. Okay, potassium chlorate when heated produces oxygen, and the mass of potassium chlorate is given to us. We are asked to find the weight of oxygen produced. When potassium chlorate is heated, oxygen is produced, and we are asked to find the weight of oxygen when 24.5 gram of potassium chlorate is heated. First thing we need to do is we need to write the balanced chemical equation, and then we can proceed further. Okay, potassium chlorate KClO3 when heated produces potassium chloride plus oxygen. Okay, now let us balance this chemical equation. 2 KClO3, 2 KCl, 3O2. Now this is balanced. 6 oxygen, 2 3 is 6 oxygen, 2 potassium, 2 potassium, 2 chlorine, 2 chlorine. Equation is balanced. Now 24.5 gram of potassium chloride is taken. So 24.5 gram of potassium chloride is given to us, and we are asked to find the weight of oxygen produced when this much amount of potassium chloride is heated. When 24.5 gram of potassium chloride is heated, what amount or what mass of oxygen will be produced? We are asked to find that. First of all, when mass is given, we use the formula mass, number of moles equal to given mass divided by molecular weight. That formula will use the number 1 formula. Okay, and find the number of moles of potassium chlorate. After that, we will find the number of moles of oxygen, and after finding the number of moles of oxygen, we can easily find the weight of oxygen produced. Okay, let's begin. Since number of moles of potassium chloride, okay, let's write number of moles only. Number of moles equal to given mass divided by molecular weight. Molecular weight, isn't it? Number of moles of potassium chlorate equal to given mass of potassium chlorate divided by its molecular weight. Number of moles of potassium chlorate equal to given mass of the potassium chlorate divided by molecular weight of potassium chlorate. Okay, given mass is how much? 24.5 gram. We are trying to find the number of moles of potassium chlorate. Remember, number of moles equal to given mass. How much is given? 24.5 gram. Okay, let us write 24.5 gram here. And how will you calculate the molecular weight of potassium chlorate? We know that very well. KClO3 means potassium means 39 plus chlorine means 35.5 plus oxygen means 16 into 3, isn't it? So 39 plus 35.5 plus 16 3 is 48. Let's add up. 8 plus 5 13, 13 plus 9 is 22, 2, 4 plus 3 is 7, 7 plus 3 10, 11 12, 122.5 here comes 122.5. So molecular weight of potassium chlorate is 122.5. So the number of moles of potassium chlorate is 24.245. Let's remove the decimal. There is a decimal number before one digit in the numerator, and there is a decimal point before one digit in the denominator, so we can forget the decimals and write 1225. Okay, you can cancel this here or leave as it is and cancel later on. So we have found the number of moles of potassium chlorate. 24.5 gram potassium chlorate means this much moles of potassium chlorate. Now let us find the number of moles of oxygen. Okay, since 2 moles, this 2 can be considered as moles. Okay, 2 KClO3, 2 is written in front of KClO3, so let us consider this 2 as number of moles. 2 moles of potassium chlorate produces 3 moles of oxygen, isn't it? 3 is written in front of oxygen. So 2 moles of potassium chlorate produces 3 moles of oxygen. Since I am trying to find the number of moles of oxygen now. Since 2 moles of KClO3 produces 3 moles of oxygen. 2 moles of potassium chlorate produces 3 moles of oxygen. How do we get this? 2 moles of potassium chlorate produces 3 moles of oxygen. So 1 mole of potassium chlorate produces 3 upon this 2 comes down moles of O2. But we have this many moles of potassium chlorate. 24.5 gram of potassium chlorate means this much. So 245 upon 1225 moles of potassium chlorate produces, this is just a unitary method, isn't it? 3 upon 2 into 245 divided by 1225. 245 divided by 1225 moles of O2, isn't it? We found out the number of moles of oxygen gas. Now, since we know the number of moles of oxygen gas, we can easily find the amount of oxygen gas produced. Please take the screenshot of this. I'm going to erase the upper part so that I get space to continue the sum. We found the number of moles of oxygen required, okay? Since now I am going to find the weight of oxygen produced. Since number of moles equal to mass of O2 produced divided by its molecular mass. Molecular mass or molecular weight, isn't it? So number of moles, we have found the number of moles of oxygen. How much? 3 upon 2 into 245. 3 upon 2 into 245 upon 1225 equal to mass of O2 produced, not given to us, we are asked to find. Let me write a little below. Number of moles is how much? Number of moles of O2 is given to us, 3 upon 2 into 245 divided by 1225. Mass of O2 produced, mass of O2 produced divided by molecular mass. Molecular mass of oxygen is 32. We have seen this, isn't it? Atomic weight is 16 and molecular weight is 16 to the 32. Okay. Now let us cross multiply this 32 here. 3 into 2, 4, 5 into 32. This 32 comes to the numerator, and in the denominator 2 into 1225 equal to mass of O2 produced, isn't it? Very simple. Let's cancel now. 2 1s are 2, 2 16s are 32. Let's cancel this. 7 3s are 21, 7 5s are 35, 7 1s are 7, 5 7 7 are 49, 50 51 52. Okay, 7 3s are 21, 22 23 24, 7 5s are 35, 7 1s are 7, 8 9 10 11 12, 5 7 7s are 49, 50 51 52, 7 5s are 35. Again, 5 7s are 35, 5 3s are 15, 16 17, 5 5s are 25. Okay, now 7 1s are 7, 7 5s are 35. Now you cannot cancel now. Okay, 3 and 16. Okay, let me erase this. Please take the screenshot. 3 into 16 divided by 5, isn't it? 3 16s are 48, 48 divided by 5. Got my point? 3 into 16 is left in the numerator, and in the denominator we have 5. 5 9s are 45. 3 decimal point comes here, 0, 5 6 are 30. Therefore, mass of O2 produced, mass of oxygen produced equals to how much? 9.6, isn't it? When we divide 16 to the 48 by 5, we got 9.6 gram. This is the way how we solve numerical problems by mole concept. Okay. First, mass of potassium chloride was given. We solved and found the number of moles of potassium chloride. After that, we found the number of moles of oxygen, and after that we found the amount of oxygen required. It's very, very simple. You can understand in a simple way. Okay students, let's go for another question to understand the concept better. Calculate the volume of oxygen necessary to burn completely 5 liters of butane gas. And second part of the question is, what is the volume of carbon dioxide formed at STP? Okay, we are provided with 5 liters of butane gas, 5 liters of butane gas, and we are asked to find the volume of oxygen necessary to burn this 5 liters of butane gas. Number one question. And another part of the question is, and what will be the volume of carbon dioxide thus produced after the reaction? Okay, this is the question. Let us first write the chemical reaction first, and then we will proceed. Butane, the formula for butane gas is C4H10 reacts with oxygen to produce carbon dioxide and water. Butane reacts with oxygen to produce carbon dioxide and water. Okay, let us balance this chemical reaction. 2 13, this is 8, this is 10, and let us see. 10 to the 20 hydrogen, 10 to the 20 hydrogen, 8 carbon, 2 for the 8 carbon, 26 oxygen, 8 to the 16 plus 10, 26 oxygen. This equation is balanced. Now let's see the question. We are provided with 5 liters of butane gas. 5 liters of butane gas is provided to us, and we are asked to find the volume of oxygen required to completely burn this 5 liters of butane gas. Okay, 5 liters of butane gas is given to us. First of all, what we do is we find the number of moles of butane gas and after that we will find the number of moles of oxygen gas, and then we will calculate the volume of oxygen gas. Please remember the steps. Okay, first volume of butane gas is given to us. Now we will find the number of moles of butane gas. 5 liters of butane gas means how many moles of butane gas? We will find that first. Okay, since number of moles equal to given volume at STP divided by molar volume at STP, isn't it? When related to volume, the formula for number of moles is given volume at STP by molar volume at STP, and given volume is, you know that given volume of butane is 5 liters. So instead of given volume of gas at STP, we write 5 liter here, 5. And molar volume of any gas is 22.4 liter at STP. We write 22.4 liter over here. This is the number of moles of butane gas. 5 liter of butane gas means 5 upon 22.4. This many moles of butane gas. Number of moles of butane gas. Okay. 5 liter of butane gas means 5 upon 22.4 moles. This many moles means 5 liter of butane gas. Okay, we have found out the moles of butane gas. Now we will find the number of moles of oxygen gas, and after that we will find the volume of oxygen gas. Now, how to find the number of moles of oxygen gas? Let's see. Since 2 moles of butane require 13 moles of oxygen, 2 moles of butane requires 13 moles of oxygen, isn't it? So 2 moles of butane requires 13 moles of oxygen. So 1 mole of butane requires 13 upon this 2 comes down 2 moles of oxygen, but we have 5 upon this moles of butane. So 5 upon 22.4 moles of butane requires 13 upon 2 into this 5 upon 22.4. 5 upon 22.4, isn't it? Moles of O2. Got my point? We have found out the number of moles of oxygen gas. The number of moles of oxygen gas is this much. Now we can find the volume of oxygen gas easily. Okay, please take the screenshot of this. I'm going to erase the upper part so that I can get enough space to continue the sum. Now, to find the volume of oxygen gas, we will write the formula. Since number of moles of oxygen equal to volume of O2 required divided by molar volume, isn't it? So we have the number of moles of oxygen. We have just found out the number of moles of oxygen, 13 upon 2 into 5 upon 22.4. 13 upon 2 into 5 upon 2.4 equal to volume of O2 required. Volume of O2 required divided by molar volume is how much? 22.4. You know that. So this 22.4 can be cross multiplied in the numerator to the left hand side. This comes up, so you can cancel this and this here. Okay. 13 into 5 by 2 is the volume of oxygen required. Therefore, volume of O2 required equals to 13 into 5. 13 into 5. Okay. 5 3s are 15. 5 1s are 5 plus 1 6. 65 upon 2. 65 over 2 means 65 upon 2 means 2 3s are 6, 5 comes down, 2 2s are 4, sorry, 2 2s are 4, 1 decimal here to find the tail, 32.5 ml, okay, sorry, liter. That means 5 liters of butane gas requires 32.5 liters of oxygen gas for complete combustion. Okay, this is the answer for part 1. Okay, and there is second part of the question. What is the volume of carbon dioxide formed at STP? I am using mole concept to solve this question to make you understand the mole concept. But these questions can be solved in another way also by applying Gay-Lussac's law and all. Okay, you can solve. So I'll let you know. According to Gay-Lussac's law, 2 volumes of butane produces 8 volumes of carbon dioxide gas, isn't it? So 1 volume produces 8 upon 2. This 2 comes down. That is 4, isn't it? 2 volumes produces 8 volumes of carbon dioxide gas, means 1 volume of butane produces 4 volumes of carbon dioxide gas. So 5 liters of butane produces 5 into 4, 20 liters of carbon dioxide gas. This can be solved by this method also, but I am applying mole concept to make you understand the mole concept. Okay, we are solving this question by mole concept. Okay, because mole concept is very important. You will need this in your higher classes as well. Okay, what is the volume of carbon dioxide formed at STP? We are asked to find the volume of carbon dioxide. Volume of butane is given 5 liter, and we are asked to find the volume of carbon dioxide. Okay, and we have seen the number of moles of butane. Let us find it again. Since number of moles of butane equal to given volume at STP divided by molar volume. Got it? I am trying to find the number of moles of butane again. Okay, number of moles of butane equal to given volume at STP divided by molar volume. And given volume of butane at STP is how much? 5 liter, and molar volume of any gas is 22.4. So we have 22.5 upon 22.4, this many moles. 5 liters of butane gas means in 5 liters of butane gas, number of moles is 5 upon 22.4. We have this much moles. Now we will find the number of moles of carbon dioxide, and after that we will find the volume of carbon dioxide produced. Okay, since 2 moles of butane produces 8 moles of carbon dioxide, you can see here 2 moles of butane produces 8 moles of carbon dioxide. Since 2 moles of butane produces 8 moles of CO2. So 1 mole of butane produces 8 upon 2, isn't it? This 2 comes down, 4 moles of CO2, that is 4. So 5 upon 2 to 4. 5 upon 22.4 moles of butane produces 4 into, this is 4, 2 4 is 4 into this much moles of carbon dioxide. 4 into 5 upon 22.4 moles of CO2. Got it? We have found out the number of moles of carbon dioxide gas. Now we can easily find the volume of carbon dioxide gas. Let me erase the upper part. Please take a screenshot of this. We have found out the number of moles. Now we are ready to go to find the volume of CO2. Okay, since number of moles equal to volume of CO2 produced by its molar volume is 22.4, isn't it? So number of moles of CO2 is, we have already found 4 into 5, that is this much. 4 5s are 20 upon 22.4, isn't it? 4 5s are 20 divided by 22.4. This is the number of moles of CO2 equal to volume of CO2 produced divided by 22.4, isn't it? So this can be cross multiplied to the numerator in the left hand side, so you can cancel this and this here. Therefore, volume of CO2 produced equal to 20 liters. Okay, this is the answer of the second part of the question. It's very simple. Okay, I am solving by the method of mole concept to make you understand mole concept. Okay, this can be solved in another way. Another way is more faster and more easier, but even then I am using mole concept to make you understand mole concept. Okay, you must understand mole concept because mole concept is very important. It helps to solve more difficult questions which cannot be solved by simple methods. Okay, let's do another question. Okay students, let us do the last question to understand mole concept better. Okay, this is the last question. Let me read out the question first. How much potassium chlorate is needed to get enough oxygen for complete burning of 84 liters of carbon monoxide at STP? This is the question. We are provided with 84 liters of carbon monoxide gas, and to burn this 84 liters of carbon monoxide gas, we need oxygen, and that oxygen is to be produced from potassium chlorate. And the question is asking how much potassium chlorate is to be heated to produce oxygen gas which would be enough to burn 84 liters of carbon monoxide gas. Okay, I hope you got the question. How much potassium chlorate is required so that it produces enough oxygen to burn 84 liters of carbon monoxide gas. Okay, let us write the chemical equation first and then we will solve. Potassium chlorate, KClO3, when heated produces potassium chloride plus oxygen. Let us balance this chemical equation. 2KCl, 2KCl, 3O2. Equation is balanced. Now, carbon monoxide burns in oxygen to produce carbon dioxide gas. Okay, now let us balance this chemical equation. 2CO, 2CO2. 2 oxygen, 2 oxygen. 4 oxygen left in the left hand side. 2 to the 4 oxygen in the right. 2 carbon, 2 carbon. Equation is balanced. 2 potassium, 2 potassium, 2 chlorine, 2 chlorine. Oxygen is 2 3 is 6 and oxygen is 6. Okay, the equation is balanced. Now, let us understand the question again. How much potassium chlorate is required to produce enough oxygen? This oxygen is produced from heating potassium chlorate. Now, that oxygen is required to burn 84 liters of carbon monoxide this oxygen is required to burn 84 liters of carbon monoxide gas. Okay, that is the question. We are provided with 84 liters of carbon monoxide gas, and our duty is to, let me give a thorough brief vision of the question and our steps that we will proceed. 84 liters of carbon monoxide gas is given to us. First of all, we will find the number of moles of carbon monoxide gas. After that, we will find the number of moles of oxygen gas. Okay, that will be required to produce to burn 84 liters of carbon monoxide gas. 84 liters of carbon monoxide gas is given to us, so we will find the number of moles of carbon monoxide, and then we will find the number of moles of oxygen required to burn these liters of carbon monoxide. After that, we will find the number of moles of potassium chlorate, and after finding the number of moles of potassium chlorate, we can easily find the weight of potassium chlorate, isn't it? Okay, let's begin. Since volume is given, so we need to use the volume formula. Number of moles of carbon monoxide equals to given volume at STP, divided by its molar volume. Molar volume of any gas is 22.4 liters, isn't it? So given volume of carbon monoxide is how much? 84 liters, isn't it? So instead of given volume, I write 84. Okay, I hope you got this. Number of moles of carbon monoxide is 84 by 22.4. This many moles. 84 liters of carbon monoxide gas means 84 upon 22.4 moles of carbon monoxide gas. This is the quantity in moles. Okay. Now, since 2 moles of carbon monoxide requires 1 mole of oxygen, isn't it? 2 moles of carbon monoxide requires 1 mole of oxygen. Since 2 moles of CO requires 1 mole of oxygen, that means 1 mole of carbon monoxide requires 1/2 mole of oxygen. 1 mole of carbon monoxide requires this 1 upon this 2 comes down, unitary method, mole of oxygen. But we have this much moles of carbon monoxide, so 84 upon 22.4 moles of carbon monoxide requires 1/2 into 84 upon this 22.4 moles of O2. Number of moles of oxygen required is 1/2 into 84 upon 224.4. This much moles of oxygen is required to burn 84 liters of carbon monoxide gas. Now, this much moles of oxygen is to be produced from how many moles of potassium chlorate? We will find the number of moles of potassium chlorate. Okay, please take the screenshot of this. I'm going to erase this. Okay, the upper part only, keeping the equation same. Since we have found out the number of moles of oxygen required, now since 3 moles of oxygen is produced from 2 moles of potassium chlorate, or 2 moles of potassium chlorate produces 3 moles of oxygen. Since 3 moles of oxygen is produced, you can see 3 in front, you can see 2 in front of KCl. So 3 moles of oxygen is produced from 2 moles of KClO3, isn't it? 3 moles of O2 is produced from 2 moles of KClO3. We got this from the 3 moles of O2 is produced from 2 moles of KClO3. So 1 mole of O2 is produced from this 2 remains here, and this 3 comes in the denominator, unitary method, moles of KClO3. Okay, you got this? Now we have how many moles of oxygen? We have, let's cancel this out. 2 1s are 2, 2 4s are 8, 2 2s are 4. 42 upon 22.4. So 42 upon 22.4 moles of O2 is produced from, let me erase this, 2 by 3 into this 42 upon 22.4, 42 upon 22.4 moles of KClO3. Are you getting my point? Of KClO3. 3 1s are 3, 3 1s are 3, 3 4s are 12, isn't it? 3 1s are 3, 3 4s are 12, 2 1s are 2, 2 11s are 22, 2 to the 4. So 14 upon 11.2 moles of KClO3. Number of moles of KClO3 required is 14 upon 11.2 moles. This much moles of KClO3 is required to produce enough oxygen to burn 84 liters of carbon monoxide gas. Okay. Now this much moles of KClO3 means how much gram of KClO3. We are now going to find the grams of KClO3. Very simple. Let me erase this. Please take the screenshot of this. Now we will find the weight of KClO3. Okay. Since number of moles, the same formula, but here in this case we will use weight formula because we are asked to find the weight, okay, not volume. Number of moles of KClO3 equal to given weight or required weight of KClO3 divided by its molecular weight, isn't it? Molecular weight. Now, number of moles of KClO3 is 14 upon 11.2 moles. We have found out 14 upon 11.2 equal to required weight of KClO3 divided by its molecular weight. You know how to find the molecular weight. 39 plus 35.5 plus oxygen is 48. 16 3 is 48. So when you add all this, it becomes 122.5. We have done this before. 122.5. Now let us cross multiply this. Okay. 122.5 into 14. 14 into 122.5 divided by 11.2 equal to required weight of KClO3. Let us cancel this out now. You can forget the decimal because there is a decimal in front of one digit in the numerator and there is a decimal in front of one digit in the denominator. So I'm erasing this, okay? Now let us make this calculation very simple. Required weight of KClO3. Required weight of KClO3 equal to 14 into 1225. 14 into 1225. I am just removing the decimals from the numerator as well as denominator. There is a decimal point before one number in the denominator and there is a decimal point before one number in the numerator. So I am just leaving the decimal points from the numerator and denominator as well at the same time. Okay. Now let us calculate. 7 2 is 14, 7 1 is 7, 8 9 10 11 4. So 7 6 are 42, isn't it? 2 1 is 2, 2 8 is 16. And now these two cannot be divided because the last digit is 5. So we need to divide 1225 by 8. Let us divide here. 1225 by 8. The number comes in decimal. 8 1s are 8. 12 minus 8 is 4. This 2 comes down. 8 5s are 40. Okay. Now 2 comes down. Now 5. 8 3s are 24. 1. Put a decimal point here. 0. 8 1s are 8. 9 10 2. We have already a decimal point, so you can put 0. 8 2s are 16. 4. You can put 0 because we have already put decimal point here. 8 5s are 40. So the answer is 153.125 gram. 153.125 gram. Okay. The question was how much potassium chlorate would be needed to produce enough oxygen so as to burn 84 liters of carbon monoxide gas completely. So the answer is required weight of potassium chlorate is 153.125 gram, so that this much gram of potassium chlorate will produce enough oxygen so as to burn completely 84 liters of carbon monoxide gas. I hope you understood the concept that I tried to teach in this video, and thank you so much for watching this video. I hope you like the video, and stay safe, stay healthy, and hey, don't forget to click the bell icon for notifications for more video uploads and subscribe my channel. Okay, thank you.